CSE technology takes 35 years of remanufacturing experience, 35 years of dealing and handling millions of cores, getting feedback from our customer through our sales force, which is the WD, the jobber, and most importantly, the professional automotive mechanic who installs our parts. Additionally, it takes our reverse engineering process, takes all those inputs, rolls it into one, which is the CSE CARDONE Select Engineering Advantage. We take that and build our program off of that. Our competitors do not have this advantage. They're not getting feedback from the professional automotive mechanic out on the street saying, I've had a problem with this, or this is hard to install, because they're on the other side of the world. They're not getting defective products sent back to them for warranty analysis, and they're additionally not talking to our customers, and they don't understand and know their needs because they're not talking to them. Outer joints. Here is a Toyota late 80s, early 90s design. Toyota started off with a 19mm thread. What happened in the field is, due to installers over-tightening, just getting an air gun and torquing the axle nut as hard as the air gun will go, the thread broke off. In the early 90s to mid-90s, Toyota went to a 22mm thread, which is a stronger design. What we've done with CARDONE Select Engineering technology, we've seen this difference, made all of our threads 22mm. Some of our competitors, what do? They just copy. So we've seen them come out with the 19mm thread and then split over to the 22mm thread. This shows that they're copying and not understanding why the change was made and applying it to their axle program. Similarly here, this is a Chrysler axle. 93 to 97, the Chrysler LHS Intrepid came out with this design. As you can tell, this thread is shorter than this thread. This is hard to install because the thread doesn't stick all the way through the hub. Chrysler made a running change, added thread length. Again, our competitors are copying OE, have this design, that design. CARDONE Select Engineering technology saw the change, implemented it because it made sense. All of our axles come with the longer thread for ease of installation. Over here, we have the 1990 to 2000 Acura Integra outer joints. Externally, these joints look exactly the same. However, there's a big difference internally. This outer joint has a smaller racing cage. This is designed to the base model Acura Integra. This joint is designed to the GSR Acura Integra, which has more horsepower over the base model engine. As a result, you're going to have more durability out of this outer joint. The one that's designed to the base model, when you put it on a car and you have a young adult put some performance modifiers on that engine, the base model outer joint will not hold up. It will actually break. And we know this from seeing them come back through the core division. All CARDONE Select outer joints for the Acura Integra are designed to the GSR specifications. How does CSE technology impact boot design? Up here we have an OE Honda Accord axle. As you can see, this has 3 bellows. We went out and bought this axle directly from the Honda dealer. This is what you would get on your car brand new. If you went to the Honda dealer to get a new axle, this is exactly what you would buy. Our competitors did a good job of copying. They have exactly 3 bellows on the outer joint as well. What we've seen from handling many thousands of cores is that when this joint goes into articulation, the boot fails here because it's under a lot of stress. So CSE technology designed a 4-bellow boot. So when the joint articulates, there's less stress on the boot, promoting longer life. That's the difference between copying and designing. Moving on to the center bar and seeing how CSE technology affects that. We all know on the Chrysler Caravan, 1990 to 1995, there's a problem with the motor mounts. The motor mounts fail, the engine and transmission sag, the axle pulls out. So what we've done, seeing many cores come back with the inner joint pulled off, we made our bar just exactly the right amount length longer. It's the correct length, it's the optimal length, meaning that if the motor mounts are new, it's not going to be too long. It's going to fit and function exactly the way it's supposed to. However, if the motor mounts fail, it's going to give it that extra length to keep that axle in the car and reducing the comeback. Looking at our competitor's axle, again, you can see the difference. They've done a good job copying OE. They have not got that input, that feedback, and make a difference, such as we were talking about. Interestingly enough, they have an inner boot on the outer joint design without enough bellows. So that means when the joint goes into articulation, you can see the stress on the boot, it's going to fail prematurely. What we've done here, we have a 5-bellow boot on this Caravan. You can see there's no stress on that boot. Wherever we have an opportunity to make an improvement, we do it. It's the CSE advantage. For center bars, another thing to consider is material selection with the heat treat. You can't simply go out and get any old steel and heat treat it any way you need. We've gone out and selected the right steel, applied the right heat treat to it, so that under high torque demand applications, the center bar will actually twist and give a little bit. If you have too much heat treat in that situation, the bar will be too brittle and break. If you have too little heat treat, the bar will be too soft and break. As you can see here in these photos, we have the CARDONE Select material with the proper heat treat. The other photo shows the wrong material with the wrong heat treat. When we received our competitor sample for analysis, we took it to a disassembly machine. During disassembly, the shaft broke. Imagine if that shaft was on a customer's car. When that would, without a doubt, break. And if that broke, it would either wipe out the transmission, the engine, or a combination of both. Our competitors say they're liable for the value of the product only. When that shaft breaks on the car, without a doubt, you'll be looking at a $1,500 to $3,000 to potentially a $5,000 labor claim. The competitor is going to only simply give you $30, $40 back for the value of that product. When you have CSE technology, you can have confidence that we'll stand behind our product. Looking at these inner housings, we have a Ford Expedition, Ford F-150 4x4 inner housing right here. Externally, nothing appears to be wrong with this housing. However, upon further inspection, you'll see the tripod roller track is deformed. It was deformed during the forging process. This housing wasn't forged properly. CARDONE Select housings are worm forged to give you a smooth, consistent tripod roller track. That smooth track is going to be vibration-free operation. The deformed track is going to cause a vibration on the car. It's going to cause a comeback. Your customer's not going to want that. He's going to lose money. You're going to lose money. Moving on, we have these Acura Legend inner housings. Again, if you'll notice, the applications I'm giving you are not obscure, obsolete applications. They are popular, high-moving applications. This is what we call a female inner housing. It's a female inner housing because there's an input shaft that attaches to this inner housing. The splines on this housing are about 1/8 of an inch too long. As a result, the input shaft will not lock into place. This axle will pull off from the input shaft. Again, you have a pull out. You're going to have a disabled car. Best case scenario, you're looking at a tow job. Worst case scenario, if this car was traveling at a high speed, when this axle pulled out, it's still going to be attached to the front tire. It's going to start whipping around. Again, it could take out the transmission, engine, or both. To show you the difference, I've gotten that same inner housing and machined away the splines to give it the correct spline length dimension. As you can see, it's a very small difference. What we've done with the CARDONE Select engineering technology is we know what dimensions are critical from the OE. We make sure we hit those critical dimensions on our axle. Furthermore, we get our product before product launch and install it on vehicles of our employees, local garages, and their customers in our Philadelphia region. So literally, we have done hundreds of on-car tests to validate our product in the field. And that's the confidence and advantage of the CARDONE Select engineering technology. What can go wrong if you don't have CSE technology? This here is a ring gear from a transmission. This, it's bolted to the carrier, which has the spider gears, transmission, the speedometer gear. This here is an inner housing for a CV joint. It got stuck to the carrier. As you can see, it moves back and forth. The transmission retaining ring is just a tad bit too big, and it actually forces this housing to be stuck in the transmission. As you can see, some poor installer had a heck of a time trying to get this thing out. He put a lot of heat to it. He cut this inner housing out. He actually drilled a hole in it. He still could not get this out of the transmission. This is not a Cardone unit. We've actually gone out, changed over competitors, and received this back through the labor claim lab because we warrant the old competitor's product. This is some of the things you can expect to find if you don't have the CSE technology. This here is a wheel hub. Your strut would attach to this, your brake caliper would attach here, and this is your CV outer joint. As you can see, the end is mushroomed significantly. Again, some installer was trying to move this from the housing. Obviously, he couldn't get it out. The whole core came back with this OE housing attached to this hub. On this particular application, Ford Probe Mazda 626, the outer joint spline actually has a little bit of a twist on it. It's called a helix, and it forces this condition. We've gone in and made this outer joint spline straight, just like every other manufacturer, just like the inner joint, just like the transmission, so that you have easy installation and removal of this application. By changing the OE design, we did not affect the fit and function, but we have improved the ease of installation and removal. Again, our competitors offshores are not getting cores back with hubs stuck in them. They don't know how to make this. They're copying. You can expect to see the same OE design flaw in their program. With Cardone Select Engineering technology, we paid attention to all the details, looked into all the critical dimensions, followed them where necessary, and improved upon them so you don't have to worry about that. And that's what gives you an advantage with Cardone Select new CV drive axles over the competition.